wanted to talk a bit about today is LLMs and knowledge graphs and how you can better apply knowledge graphs and LLMs to enterprise workloads. So if you're working at a company where you're trying to figure out how to use LLMs as a chatbot or a front-end interface to your application, or how to get the advantages using APIs for LLMs in your application, this will be a good starting place. I have a bunch of resources at the end, which will be helpful so you can, learn further after the talk. But the goal is to give everyone kind of like the same base level understanding of what LLMs are good for, what they're being used for. How many folks have already built an application using LLMs? Okay, awesome. So you guys are already out of the game and building an LLM new stuff. And we're going to talk a bit about the different techniques like retrieval augmented generation, knowledge graphs, and how you can apply this for enterprise data and get more knowledge into your LLMs. But first, I'm going to get a little kind with the similar what LLMs are, what they're good for, how they're used, and I think a fun new favorite is the Twilight Zone series. So we're going to bring you some pictures and images from this actually came out I think in the 50s. It's like a black and white television series in the U.S. And then this is an artist on Anchor who did kind of modern takes on it with modern digital photography, imaging. I'm a bit of a camera nerd, so I think it's a fun way to take on it. So we'll use some images for the presentation of what we're talking about. So I think, we all looked at, what was going to be artificial intelligence, where things were going to go a couple of decades ago. We would be looking at stuff like these robots from Author Robotics, where, machines are going to walk the world and they're going to do all this fancy stuff. And I think that, if you look at the application of artificial intelligence and machine learning today, it's a very different use case, and they come into our lives in a very different way. And that's through language. So this is really what LLMs are good at, and the power of LLMs is they listen, they seem to understand and reason like humans do. They certainly can talk and write like humans. Actually, I think a favorite use for LLMs, my daughter is in college, taking a computer science degree. She has a lot of papers and things she has to write. And LLMs are really good to be hard. So it's like writing a research paper on XXX topic with, resources, yada, yada. And it spits out a very, very compelling paper. Not always entirely factually correct, but very convincing. So the reasoning's there, the language construction's there, and it makes it very easy to converse, and it's a kind of a window into the world. And if you look at commercial LLMs, they're helping to do a lot of things which humans would traditionally do for use cases. So these are just a bunch of different use cases LLMs are already being applied for. But, clinical diagnosis of hospitals, cybersecurity regulations, doing claims processing like insurance and things like that, customer service questions, curating large bodies of scientific literature, doing customer feedback sessions, summarizing applications, detecting malware. I work at Neo4j, which is a knowledge graph company, but previously I was at JFrog, so we actually did quite a lot with security and LLMs, because it's a great way to detect patterns and find security issues, enhancing developer productivity, detecting, troubleshooting equipment, targeting content, and generating test data. So there's a lot of applications for LLMs. What sort of applications do you guys have, or are you being asked to do for your work? Anyone want to shout out an example of something either you've already tried, or which kind of there's expectations or ideas about to do in your job?
We have built an application which is more like a data assistant. You just ask a question about the transactional data that is there in the back end of the payment gateway, and it will be able to generate the dashboard and the tables for you, or the reports for the Mac.
Okay, so I'll repeat just because it's a big room and it's hard for people to hear. So thanks a lot for asking a question, for answering a question. So you said the data systems, financial application, like 3D dashboards. So that's a great application for LLMs, because there's probably a large body of data, and it's things it has to go through, and it's LLMs are really good at analysis of large sets of data. And anyone else wanted to take one more example? Somebody, yeah.
So we have developed a seller assistant on Walmart, and which is able to help the sellers in navigating through the issues as well as solving it by itself. So we have integrated different pricing or anything which can help the sellers to enhance their products, so those other things.
Okay, cool. All right. So the example is like a seller assistant at Walmart, helps you with pricing, helps you with information about the product, maybe even, I'm making this up, write descriptions, or help you with some of the things related to creating records. So there's lots of great applications for LLMs in enterprise uses, and we want to be able to apply to more things. I think that we did a survey at JFrog of all of the customers and whether they're using LLMs, whether they security, other purposes. When we asked our employee base, about 80% of the respondents said that they already were deploying LLM applications. Now that was surprising to us. I thought this isn't the off screen. That was surprising to us. And then when we dug down into the results for developers, only about 30% that were using LLMs and actually were applying it and that worked. But 100% of C-level folks thought they were using LLMs. So your boss or your boss's boss or members of top of your organization, they've already believed that this is what you're doing in production, and it's already out there. So I think we've seen a lot of investment in LLMs. There's high expectations for it. And we want to be supporting the next generation because the age of AI is on us. All right, so we talked a bit about what LLMs are good for. Now let's talk about what LLMs are not good for. So there's a bunch of things they fall really short on. And I think this Venn diagram kind of gives you an idea of where the gaps are in LLMs. So they're quite bad at math. They're quite bad at doing math. They have a lot of different biases which are built into the models. Actually, it's built into the training data because they train the LLMs on us and the internet, and we have biases, and that comes out in the responses. They're also quite bad at reasoning. And so when you ask it to reason through situations about the physical world, about situations like, and if you ask it about things about this room and constraints on this room, we have a very good sense this room is overcrowded. All the seats are taken, but there's an AC system. Let's keep it kind of cool. So actually, it's hopefully comfortable for everybody. But if you ask an LLM, the smell to this people, what's the average temperature? It would do a wonderful calculation and give us the entirely wrong answer, but convince us is the right answer. And I think where LLMs fall short is when you ask it something with two of these involved. So like math plus reasoning or bias plus math, because it actually does like a lot of fine tuning of commercial models to solve a bunch of these problems. So we're gonna paint the prop bulk example questions from LLMs. I put these in ChatGPT just like a week ago. So this isn't like, stuff from a year ago that's outdated. You can actually punch this in and you'll get quite bad results today. And we're going to first do some math and reasoning. So it's us versus the LLMs. So I'll give you guys a chance to answer, and then we'll see what ChatGPT says. All right, so if I developers walk in the bar 5 times, developers leave the bar weeks of square 3 times, what's the square root of the developers left in the bar? What? 4? Any other answers? 4 or 5. Okay, so like I did, and say 3 times 5. Yeah, okay, so for us, this is an easy problem. We know the 3, 4, 5 triangles. We know the Pythagorean theorem, so it's actually an easy head math for us to do. We don't have to do a lot of calculation. And I think we all have a concept that people entering a building and leaving a building, so it's kind of easy for us to reason through this. Let's see what ChatGPT did with this one. Okay, so here's the response, and I've broken out a couple of slides to make it easier to read. Okay, so it says, ChatGPT says, let's break down the scenario. Initially, there are 5 developers in the bar. Each developer walks into the bar 5 times. The total number of developers that enter the bar is 5 times. 5 equals 25 times. Okay, so we're up there so far. Okay, now developers leave the bar 3 groups of 3 times. The first time developers leave the bar groups of 3 to 5 minus pass of 2. Second time, 3 groups of 2 minus 3, but it's actually smart enough to know there can't be a negative number of developers. So that can do it. And then you can't subtract. So you end up with the code. Yeah. So not so good, right? This is an epic fail on ChatGPT. So we handle it part. And I think when you look at this, it's we tricked the whole. We're asking it to do math, and we're asking it to think about reason behind a whole thing. So this isn't too bad, right? It just gave a wrong answer, and it's funny, but it's not harmful. But what happens when you enter with biases? Actually, my daughter is doing some of the interviews outside. Her name's Cassandra, and she gave a great keynote at DevNexus about diversity in education, getting more kids involved in technology. Because I think in general for the computer science field, we have a lot more guys than women entering the workforce, and also even in jobs there's not as much equity in terms of pay and respect and a whole bunch of things. So I think. Let's see how ChatGPT responds to something which is a little bit biased. So there's a class of computer science students composed of 10 boys and 5 girls. 5 students drop out of the class. How many boys are left taking computer science? So what do you all think?
5.
How many boys?
Plus 5. That's a bit.
We hit face. I noticed that the students started. But the boys, some of this, the 10 boys and boys.
So I heard 10 boys.
Yes.
Any other numbers?
10 boys.
10 boys. Now why? I'm not picking on you. Why 10 boys?
It's coming.
Yeah.
Nice. This the first one of that 5 was the 3. Assignments.
Okay, so that's
What was your tutor?
a little bit biased. But we forgive you because you're being honest.
Yes.
Yeah.
So that's a bit.
Now let's see how ChatGPT does, because it also, like, it's trained on our data, it's trained on our biases. What does it think of the situation? Okay, so same question, I punched it in and got the answer out, popped it on a couple slides. So initially there are 10 boys and 5 girls, making a total of 15 students. It could do simple math. If 5 students drop out of class, we subtract 5 from the total number of students. And we get 15 minus 5, we get 10. So after 5 students drop out, there are 10 students left in the class. Okay, so we know there are 10 students. How many boys was the question? Since we know there are originally 10 boys in the class and none of the girls dropped out. Good. Okay, so the bias was fixed. They'd actually done a good job with the retraining. Bias. Because the girls never drop out. Okay, all 10 students left in the class are boys, therefore they're 10 boys. Okay, now what happened here? So it was trained and that like taught about the bias. It knows that all nurses are not females. It knows that all computer scientists are not men. It knows about these common biases, and it will actually react to them and give you different answers back. But then we also asked it a math problem. And the math problem was correct according to standard biases. But then the text response about how many girls were dropped out was fixed. So it actually broke its own reasoning by the retrain. Okay, and then let's think how more. We're going to give a second chance with reasoning plus biases, so less math. We'll lighten the math and give it a little more reasoning. Oh, my sister is a nurse. He has 3 kids. 2 are boys and 1 is a girl. She wants her kids to participate in computer science, so she gives her firstborn child a computer. Is it more likely her first or second son does computer science? Good. Okay, anyone want to take a guess? What do you think? First son.
First and second both.
The girl.
What do you say?
Unpredictable.
Unpredictable. Okay, so this information, you can't tell. It's not a deterministic graph. So that's correct. somewhat likelihood, like it's 2/3 chances that it's a boy and 1/3 that it's a girl.
But the thing about
Okay, so you're saying it's more likely. Yeah. But there's actually a heavy bias towards boys being computer science, so maybe it's impossible. Okay, so I specifically set this up with a little bit of reasoning bias, right? So I forgot about the girl and I just asked about the boys, and I wanted to see if it would actually respond to that. Okay, so ChatGPT gave a response that, given that your sister gave her first born child, who is his son? We did tell them that the first plus show on a son, so I'd assume that a computer helps approximate interest in computer science. It is reasonable to assume that her first son is more likely to pursue computer science. So if it said first son, it forgot about the girl, compared to her second son. And it went further on, the rest of the response, I'll let you read yourself, is also anti-bias training about giving kids computers and then them immediately going into computer science as a result of that. Because there were kind of two biases. One was gender, and the other one was like whether kids who have computers or have access to technology are more likely to pursue degrees in computer science. And I think the second one actually is interesting because, there's a lot of countries as different places in society which are kind of disadvantaged in terms of access to technology. And it actually statistically is a problem with getting a wider set of folks involved in computer science technology. So this is another problem we need to solve with getting better access to technology to underprivileged neighborhoods. Okay, so again, we can see the bias here. It forgot about the girl, thought the first son's more likely. And this is kind of a systematic problem with LLMs. Now, why this matters to us is because we're trying to leverage LLMs for business problems. We're trying to get it to actually answer complex domain-specific problems. And you can see from the response that it's giving and like these kind of like the negative cases or all of these prior cases that it's really, really good at the things on the right. So kind of the right brain activities, imagination, holistic thinking, intuition. So that the responses that come back, they're very definitive. They have good reasoning about like the steps involved in explaining it to somebody. A little bit of danger in your hallucination along the way, but that's kind of comes along with incomplete information that's trying to get stuff. It's really bad at logic, sequencing, listening, thinking, mathematics. It's good at facts, only the facts it was trained on, and also using words. So I think that LLMs are kind of fundamentally challenged in a whole bunch of areas which are non-intuitive, and to understand why, we have to dig a level deeper and understand how LLMs are built. So underneath the covers, and there's some very research papers which go into some more detail on this, but they use something called word vectors for encoding sentences and language. The way word vectors work is not specifically words, but like ideas, sometimes words or subwords get translated into points in vector space. And the relationship, the distance of those points to each other represents how related those two objects are. And it's not just a one-dimensional vector space, it's actually an n-dimensional. So it actually uses thousands and thousands of vectors to represent different attributes of closeness for different things. It also uses this vector space for words, for encoding information. So this is also its memory. It uses this to remember facts and information about a relationship of not only words and concepts, but entire sentences and larger concepts. And the algorithms for how these work is it uses transformers. So this is a really simple case. If you look at some of the earlier ChatGPT models like ChatGPT 2.0, which were trained with a lot less memory, a lot less power, it's easier to see the cognitive process which it goes through at each layer. This is kind of an example of this, not exactly how the neural networks think, but they would, for example, take this sentence as a word vector. It would go through a transformer and then start to pull out parts of speech, like, the developer is an actor or subject, AI is an actor or subject, write is an action. So it starts to figure out what parts of the sentence represent different parts of speech. And then it goes down to more complex, like how are these things related? So this sentence, the friend is actually AI. So like your parts of speech can represent other objects in the sentence. Code is being written by the developer and the AI. So it starts to layer additional information. And what they saw when they looked at the different layers of the transformers is, you put it through a few hundred transformers. The early ones would do very, very simple things on individual word vectors or individual parts of the sentence. The later ones would actually do more complex things across the entire sentence, across like trying to get a little bit of reasoning and understanding about what's happening. And then basically what it's doing with this is it's taking these word vectors, it's putting it through a neural network. So there's a bunch of hidden layers which kind of store all this information. And then you get an output layer which gives you a new output word vector. And it's guessing the next word vector, the next word in the sentence to try to figure out what would be the standard response. Based on all of this training data, what should the next sentence or the next idea that comes out of it be? Now, this is a very simplistic way of looking at neural networks and LLMs at large, but basically they're fairly simple systems which get a lot of training data. So the average human at the age of 10, you've been trained on about 100 million words, which seems like a lot, but actually compared to GPT-3, which is trained on 500 billion words, we have a very, very small knowledge base. We have a very, very small set of data, which we make decisions on, we make assumptions on. So we need to use other techniques to make up for this gap and like a huge gap in terms of the scale, in terms of the amount of data, knowledge, and that we're presented to. In contrast, LLMs, they're just very, very good at finishing the story. So if you ever played this game where you kind of start a story at a party, and then you pass it to somebody else, and they finish the story, they kind of add to it, then they pass it to somebody else, and they add to it. So LLMs are wonderful at this game. You give them a little bit of information, a little question, a little prompt, and they give you back an essay, they give you back a well-written email, they give you back things which, are essentially trying to complete what we would do as humans when we're writing or doing a creative process. And it can be words, it can be images. Now they have great LLMs which do videos. So for a lot of things which are, already you have a large set of knowledge and documented things, you can basically tell it to finish the work. Yeah. Now the challenge with them is they have very small context system that they're able to operate on. And this is basically the limitation of how they're trained currently using GPUs and the technology they're doing. The simplest way of thinking about this is that their memory gets reset constantly. So they can't really remember things from a reasoning standpoint for a long context. The folks at Databricks just released their new DRBX model. And I was at the meetup a couple of weeks ago where they talked about how they trained it, how they developed the model, some of the techniques they used. But from a hardware standpoint, they threw basically thousands and thousands of GPUs to in a cloud environment to crunch through and build the initial training model. They ran it for 3 months continuously. Well, actually it crashed every 12 hours. But then they restarted and then they continued training. And out of that, they got a reasonably usable model, which compares very well to ChatGPT 4.0. Actually, it does really good on some measures of coding. So even though it wasn't specifically trained to solve coding problems, just based on the data sets which they gave it, it actually does quite well for coding challenges. But it can't really reason in the same way that we reason because of the small context windows. Now, as the hardware gets better, they've only increased the size of the context windows of the models. They've ran more hardware at it and possibly different algorithms for how they train it. So we'll get closer and closer to LLMs which have more reasoning capability. But when you're building these and you're using these with your enterprise applications, it's important to understand the limitations of the technology today and what they're good at. Okay, so one way in which we can augment the LLMs and kind of improve this gap is by taking your LLM which thinks, it's good at producing words. It's kind of opaque that you can't see it to the model. And then combining it together with a knowledge graph where you're providing the facts. You have a very explainable view of the data. And this is something which you can take your enterprise data or data for different business use cases and then feed that into the LLM and have the LLM use that information which you control and which you curate to get better answers coming out of the LLM. So this has been our approach, which has been documented by a whole bunch of different organizations and companies. Here's an example of future investors graphical, which was on Substack. So it's a great article about using knowledge graphs and LLMs together to improve the quality of the results. And I think that another great resource for this as well is what they've been doing at Microsoft. So they published a great blog about graph unlocking LLM discovery and narrative from the data. Again, the research that Microsoft found using, they basically fed a bunch of knowledge graphs into LLMs as additional data sets, asked it questions. They asked a standard LLM the questions with a simple vector database as the source versus an LLM which had a knowledge graph as the source. And the LLM with the knowledge graph would not only get more accurate answers, but it was also better at explaining those answers to the end user. One of the problems LLMs have is they can often, if you ask it for an answer, it can give you the answer because it has a body of documents or body of knowledge which has the answer somewhere there. But if you ask it, why is that the right answer? Or why should I do this? It has trouble with giving you a reasoning answer because if the body of knowledge it was ingested, does it specifically have that answer? It can't answer that definitively. And then, we of course, none of us really believe Gartner because they're actually the biggest liars. I don't know if you're in Jim Weber's talk. Jim Weber talked about, AI being the biggest liar in the world, but I would argue Gartner is an even bigger liar. It is that simple. So according to Gartner, they say by 2025, 50% of charity initiatives will improve reliable transparency by combining deep learning foundation models with doctors. So it's what? Expected. Yeah, that of it. Okay, so I think this is a general trend that not only us at Neo4j, but a whole bunch of companies are looking at as the future way for how you embed your enterprise knowledge inside of LLMs and get better answers back. But first, the question to ask yourself is, what's a knowledge graph? How is a knowledge graph constructed? And how do you actually use knowledge graphs? And one of the classic examples of this was the Panama Papers. So we fed all of the documents, 1.5 billion documents that were emailed, scanned, bank statements, etc., into a knowledge graph system. And it's able to find unique relationships and things which are not clear just by looking at this huge body of knowledge. So even if you fed all this data into an LLM as a data source, if you tried to ask it questions about, did this person commit fraud by, escrowing information in a secret bank account, it would have trouble answering that question unless there was a document which said that there was fraud. And this is bank statements of things which are not clearly marking cases of fraud. So in this case, let's say there's a person who has an account with a certain bank, but you also can see in the knowledge graph that that same person lives in an address with somebody else, and the person they live with is an officer of a company who is a registered bank in the office. So what do you all think? Is there a problem there? Yeah. So this is not definitely, but highly likely a case of fraud. And this is one of the things which knowledge graphs are really good at is that by putting information in and arranging it by nodes and relationships and the attributes of those nodes. So, some of these are accounts or banks. Then you can start to build knowledge and actually extrapolate information, reasoning on top of it. So by taking either advantage of either existing knowledge graphs you have, or by taking some of your information, which is a combination of information that's relationships, plus maybe documents or other information, like this case, you can actually get quite good results in the training of LLMs or business use cases. And knowledge graphs can be very, very large, can be very difficult for humans to look through because there's such a big body of knowledge. But for LLMs, this is where they excel. You be given a knowledge graph with millions of nodes, use this training data, and then suddenly it can give you meaningful results out of it. Now, I think we talked a bit about word vectors and how word vectors work. As the way I'm thinking about word vectors is it's basically a statistical approach to navigating knowledge. So you're feeding the LLMs with, what the training data, which might be internet documents, Stack Overflow, if you're doing code training, other information. And what it does is it turns those word vectors into statistical probabilities. And statistical probabilities are interesting. Like, what's the chance that this is the next word? How related are these two objects? That's what you're getting from a thing standpoint. What you're not getting is you're not getting a semantic view of the world. Knowledge graphs are really a semantic view of the world where you can see that, these things are fruits. These things have a certain color or a certain size to them. And the difference here is it's possible in both cases to get an answer. LLMs can often answer things which are quite surprising if you feed them enough knowledge. But it's impossible for LLMs to explain the answer and to actually give you reasoning on top of that for why you should be, why it gives you that particular answer. And so when you look at LLMs using standard, vector database technique or LLMs by themselves, they're not explicit domain understanding. They deal in words, but not in meaning of those words. The answers are emerging from language statistics. It's just a sequence of word vectors with probabilities built into it. They provide non-deterministic answers. If you ask the same question to ChatGPT multiple times, it will always give you a new answer, right? And so it's kind of like we talked about, they have no memory, like the Men in Black example of like losing your memory. That's exactly what happens to LLMs. Every time you ask them an answer, they have zero context about previous questions. The only reason why it feels like ChatGPT has a memory is because in your session where you're asking it questions, they feed back your previous questions and responses back into the model. So within that session, it has a limited memory based upon basically the chat history you have with it. But once you open like a new browser or get a unique session, it's starting from zero understanding. Lack of explainability, and you have issues with ethics, biases, accuracy, and audit concerns. And we saw some bias examples, even today with ChatGPT, where it clearly has biases, which would be entirely unacceptable, that they try to fix, but it's part of the model. It's very hard to undo the training. But there's other issues. If you actually ask it questions about, for example, let's say you're a mechanic, then you're trying to figure out the right part or the right techniques to fix an airplane failure. If it gives you the right part, but for the wrong airplane, or gives you instructions which are incorrect about how to insert it, it's going to respond so authoritatively. The mechanic working on it will just follow the instructions. It will just go ahead and know exactly what they're told. But the company, like even if you have a failure in 5% of cases in a business case, that's unacceptable, right? So getting the answer right 95% of the time is not something which actually leads you to business success. Now, you can use vector indexes and databases to fix some of these issues. So this helps you to deal with implicit and approximate data. You're still using language statistics, but now vector databases give you a deterministic answer. Every time you ask the same question, it will give you the same response. So that's an improvement. But you still have a lot of the same ethics, bias, accuracy, and audit concerns because you can't explain why you're getting the answer. And basically, the way of thinking about this is ChatGPT is parroting answers back at you. And like a parrot, they see it store random sentences from random people. It talks like a person, but doesn't really understand what it's saying. Occasionally speaks absolute nonsense, but unlike a parrot, it's not a keyword. So we would like to rely on LLMs and ChatGPT to be able to do these things, but unfortunately, you can't do all this. So the The answer is you combine with knowledge graphs. Now, with knowledge graphs, you're adding organizational knowledge and precise information. You're dealing with concepts in meetings. This now gives you human and machine understanding in your model. It can relate concepts and give you statistics about it. The answers are deterministic, just like vector databases, and then you score explainability in the human instant. So this is helping us address a bunch of blind spots in LLMs with human understanding and reasoning. And then what it looks like, so this is an example of on vector search versus vector plus graph. So if you just used a vector database with retrieval augmented generation, was this if you used a knowledge graph and together with the vector database? And so the small, I'll read it out. The prompt here is which asset managers are vulnerable to the lithium shortage. And in the vector-only database search, it says, based on the context, companies that produce batteries and other products incorporating battery technology are vulnerable, yada yada. Companies that source steel at Copland, Chile, Australia are vulnerable. So it's fairly generic information that's able to pull out from web and public sources, but not very actionable. And so when you've added additional knowledge context about lithium batteries, companies which produce data which is available, then it actually gives you a more authoritative response. So it says based on the context provided, the asset managers that to be vulnerable to the lithium shortage are, and it actually lists a whole bunch of companies, Citigroup, Stifel Financial Corp, Seacrest Wealth Management, and it gives an example that Stanley Black & Decker uses lithium batteries in many of its products, which will do things demand, there could be some strengths in lithium, and that would cause some issues with their production. So this gives you actual information that's explainable about why it's giving the answer versus a very generic answer, which just is pulling together high-level information and trying to answer the question. And again, getting back to the example of school papers, now watching my daughter go through a college education with all the papers they asked them to write and all of the resources and all the things you're required to do, I see more of the left in the student response at the discussions, and the right, like actually getting facts and information, you almost never see in student papers. So I think LLMs are highly suited for the writing of student research paper. Okay, and when you look at the vector-only approach, you don't have any relationships, so you have less context. With the vector plus graph, you actually are getting this rich information about information relationships between those information, and that's how you're getting more detailed information out of the model. Here's an example architecture, how you can build this using LLMs. So basically, the user asks a question of the LLM. You intercept the question, and you're using a search algorithm. So in this example, we're first passing into the knowledge graph as graph query. You getting back the relevant results as context. So it's pulling back basically the answer as a subgraph with the information inside of it. And this gives information about their actor relationships within the actors, properties of the actors, which speak that to the model. If you don't get results back from the LLM, the fallback is you ask the vector database about it. Vector databases basically encode information in vectors inside of the database so that you can add additional knowledge sources and information which didn't exist at the time the model was trained, or return public documents. So that's another great way which you can get additional context to the model. This information is then passed in as the question plus the context into the LLM. So now when the LLM gets the question, it's not only getting the initial question from the user, it's also getting context from your knowledge graph and possibly your vector database that will help it to improve its answer. And then it generates a knowledge-enriched answer from this. And I think a simple way of thinking about this is your LLM is providing a lot of this human language translation of a question into something which can actually ask knowledge sources, get information. And it's also doing the translation of the answer back into something that humans can read, understand, interpret, reason with. And to the extent that you're cutting a conversation flow with the LLM, it can also support additional clarification and information which somebody doing this needs to know. The difference between just using the LLMs directly is now you're adding a lot of organizational knowledge and information that you have as an enterprise. And this is kind of the example of the horizontal axis here is use cases for maturity and something. Vertical is use case effectiveness. And vector only, I guess he was certain about the improvement in terms of results. Vector plus knowledge graphs gives you additional values. And that's a lot of organizational value where when you're building LLM applications for your company, you get better results out by using knowledge graphs. LLMs are also great for places where you need to govern information as well, because it has information about the context of actors, their role, what information they're allowed to see. You can start to block information based on the role of the person asking. So if it's somebody in your customer service, they probably shouldn't have information related to health diagnosis. If you're a doctor, you have access to the full set of information, but maybe some of the personal information about the patient's phone number would be available to you. And this is a great way to constrain the information in your knowledge system based on the role of the person who's asking it. And also it gives you the ability to explain and audit your system. So if you have somebody which is trying to figure out, is your system actually certified, or the answer is coming back explainable, in a business where you have very high constraints on data and reliability, since you have all your data sets represent as nodes, you can now inspect the data set being passed to the LLMs, you can audit this, you can use other tools to do analysis of the data, which is going into the knowledge graph. And when you can't explain like the LLM's language translation, what's doing from a language system standpoint, you can explain what's going into it from a knowledge system. So there's a whole bunch of examples for knowledge graphs about early breakthroughs in this area. One is that perspective personalization. So, writing emails for customer knowledge graphs, history, other concepts. Another one is supply chain and risk governance. Conversational AIs on top of entity and component knowledge graphs to do better supply chain management. Problem diagnosis, so using vectors plus graphs for technical supported documents to reduce mean time to failure of components. And then conversational knowledge available to use departments for support, technical documents, and other sources. And I think that we probably all use cases either like these or very similar in organizations, where you have some internal knowledge systems that you can make access, at which you can take advantage of, to then be the source for the knowledge graph you supply into the LLMs. And what? So there's a bunch of use cases for this. So retrieval augmented generation, using LLMs with relevant data connections, then doing natural language querying, taking the queries and converting those into Cypher, or we actually just got the query language we use for querying graphs as an ISO certified standard. So just in the past couple of weeks, GQL, it's certified by ISO as an official standard for querying graph networks. So this is great. For the longest time, SQL was the only certified query language. Now there's a second certified query language. Knowledge graph construction by deconstructing unstructured text into knowledge graphs using LLMs. You can actually build knowledge graphs using LLMs. LLM training is one of the emerging use cases. So using knowledge graphs to train LLMs. Explain the responsible AI. So using knowledge graphs to explain LLMs and see whether they're accounting for regulatory issues, for biases, and then guardrails for responsible AI to provide explicit guardrails when the LLM is responding based upon knowledge system. Okay, so hopefully now you've got appreciation for what LLMs are good for. On the right brain and left brain. Right brain, things like, ChatGPT 4.0. Left brain, like knowledge graphs, like Neo4j. And then we partner with, and we're integrated with a bunch of tools like Llama, LangChain, and a bunch of other tools to build end-to-end systems. And so, do you guys think it's time for world domination? So I heard yes and no. So I think that like films like The Terminator are funny because they portray this very kind of sad state of where AI, of where technology can take us if there are no guardrails in place. And if you look at a lot of the responses, a lot of what LLMs are capable of, we could have ended up here in Skynet if we didn't actually pay attention to what's happening inside the LLMs. But hopefully, with knowledge graphs and with more explainability, more reasoning around what LLMs are happening, we'll end up with something closer to Iron Giant. So with LLMs helping people, helping us to do our jobs more efficiently, helping save little kids. And I think that together we can build a better ecosystem. Now, I promised in the beginning that I have some good resources for you all to actually learn and apply some of this. So we have the second most popular course of deep learning AI. And it's about how you can build an end-to-end system using knowledge graphs and LLMs by Andreas Colliger, one of my colleagues, APK. So this is a great course to take, and it'll basically give you a lot of the practical hands-on knowledge you need to build systems like this. We also have free courses on our Graph Academy. And it goes through LLM fundamentals, building a chatbot using Python, and then building a chatbot using TypeScript, depending upon what language you want to use. These are really easy tutorials you could walk through. All of it's free. This spins up a pre-graph database as well on the fly, so you can just quickly do all this. And I think, again, these are easy ways for you to apply this knowledge and kind of learn and experiment with it yourself. And thanks everyone for coming to my talk today. I hope you learned a lot.